Hello everyone, this is Dr. Ranjith Kumar Gatla, working as an Associate Professor in Department of Electrical and Electronics Engineering. In this class, we are going to discuss about the course name is called Electrical Circuits. So this Electrical Circuits course is there in BT 23 syllabus for first years EEE students as well as ECE students. And when coming to the course code, which is AEED02, and the category of the course is at the foundation level, and the number of credits for this course is 3 credits. And before going to in detail about the course syllabus and all, so first let me explain the course overview, and then after we will discuss the course objectives, then the course outcomes. Because as we know, the Institute of Aeronautical Engineering is adopted the outcome-based education system. So in outcome-based education system, so the course outcomes are very, very important, because at the end of the course, we will check whether the course outcomes are attained or not. So here, when coming to the course overview, this course overview presents what are the different concepts that we are going to learn and why these concepts need to learn, and then what are the applications of the concepts which you are going to learn in the electrical circuits course. So here, the course overview is, this course introduces the basic concepts of the circuit analysis, which is the foundation for all the subjects of the electrical and electronic engineering. So that's why this is the foundation course for electrical and electronics engineering, not only EEE students. Okay, so this is the foundation course for the electronics and communication students also. So this course introduces the basic concepts and as well as the fundamental laws of electricity as well as the magnetism, with the emphasis of the basic electrical elements such as resistors, inductors and the capacitor circuits applied to both alternating as well as the direct current. Which means in this course we are going to learn the basic concepts of the various basic concepts of the electrical circuits, and as well as the basic laws which are associated with the electrical circuits. And the electrical circuits consist of the basic electrical elements, which are the resistor, inductor and as well as the capacitor, which is nothing but it may the circuit may contain only resistors or only the inductors, okay, or the combination of resistor, inductor and the capacitor. And here these circuits we are going to discuss both with DC excitation as well as the AC excitation. So we will discuss what is DC and AC and the difference between the DC and AC in coming classes. And further, this course also provides the various network theorems or the procedures to apply various network theorems, again with the different excitations, which means both DC and AC excitations. And this course also provides a basic knowledge about the two-port network parameters and as well as the network topology to solve the real-time applications. This is about the course overview of the electrical circuits. And next, when coming to the course objectives. So here the course overview give us a brief idea about what are the different concepts that we are going to learn and why we are going to learn and where we can apply these concepts in the real-time applications. So that we can get the information from the course overview and from the course objectives. So what the course objectives will represent means what the students will try to learn from this course. So because before taking the course, the student should know, okay, so what are the concepts that the student is going to learn. So here the course objectives defines what the students will try to learn from this course. So here there are 4 course objectives are defined, and coming to the first course objective, which is the network reduction techniques. So here the students will try to learn the various network reduction techniques such as the source transformation, mesh analysis, nodal analysis, and the network theorems to solve the different networks, or to reduce the complex networks into a simple networks, or to find the current flowing through an element or any element or the voltage across any element. So the students will try to learn from this course is the network reduction techniques. And next, when coming to the course objective 2 is the students will try to learn the basic concepts of AC circuits for optimization of household and industrial circuits. As we discussed in this course, we are going to learn all the network reduction techniques including network theorems with both AC and DC excitation. So which means in this course, the students will try to learn the basic concepts of AC circuits and as well as the characteristics of the AC, alternative current, or the basic properties of the alternative current. These things the students will try to learn from this course. And when coming to the third objective, the various configurations of electromagnetic induction used in magnetic circuits. So the various, which means the students will try to learn the various configurations of the electromagnetic induction used in the magnetic circuits for what, which will, these concepts will help in winding of the electrical machines. Which means these concepts, the concepts are the electromagnetic induction used in the magnetic circuits. These concepts will help the students to understand the basic concepts or the basic working principle of the electrical machine. And when coming to the objective 4, the characteristics of the two-port networks and network topology suitable in the power systems. So just now, as we discussed, this is the foundation level course, and this course is the foundation for all the courses which an electrical or an electronic student is going to learn in his further semesters. So that's why these concepts are very, very important. So that's why this is the foundation course for all the courses which the student is going to learn in upcoming semesters. And then when coming to the course outcomes. So of course you can see, the same similar concepts will repeat in course objectives and outcomes. But the major difference between the course objectives and the outcomes is the course objective is what students will try to learn from the course. Okay, which means at the beginning of the course, the students can able to know what he is going to learn from that course. Okay, but the course outcomes are, as you can see, the course outcomes, and every course outcome start with a statement. At the end of the course, students should be able to do. Okay, so after successful completion of this course, okay, so what the student can able to do from this course, or by taking this course, or by understanding the concepts, okay, where the students can able to apply these concepts. Those things are defined by these course outcomes. And when coming to the first course outcome, which is CO1, is define the various terminologies used to study the characteristics of DC and AC electrical networks. Which means after successful completion of this course, the student should be able to understand the difference between the DC and AC electrical networks, and what are the basic terminologies which we are using to understand the characteristics of DC and AC electrical networks, which defines the CO1. And when coming to the course outcome 2, so at the end of the course, or after successful completion of the course, the student should be able to demonstrate different laws and indirect quantities associated with electrical circuit for branch currents and nodal voltages. Which means after successful completion of the course, the student should be able to demonstrate the various laws which are associated with the electrical circuits, and as well as the indirect quantities, okay, which will help to analyze the electrical circuits, which means again the network reduction techniques are the basic network reduction techniques are the nodal and mesh analysis. And when coming to the CO3, again after successful completion of the course or at the end of the course, the student should be able to summarize the procedure for several theorems to reduce the complex networks into simple equivalent network with DC as well as AC excitation. Which means the student should be able to summarize, because the various network theorems having various procedures. Okay, so every network theorem has their own procedure to reduce the complex networks into the simple equivalent networks with DC and as well as the AC excitation. And then when coming to the CO4, describe the electromagnetic induction, magnetic flux, self and mutual inductance in the single coil and coupled coils magnetic circuits to know magnetomotive force and the total ampere turns value. Which means this CO will help the students, or this CO, okay, after successful completion of the course, the student should be able to describe the various the terminologies or the basic definitions which are associated with electromagnetic circuits, which we are going to use in electrical machines concept, like this electromotive force or magnetomotive force, EMF, and what is MMF, okay, and what is the total ampere turn values. So these things the students can able to understand and then can able to apply these concepts or understand these concepts, okay, so to better understand the concepts of the electrical machines. And then when coming to the course outcome 5, at the end of the course, the student should be able to develop 2-port parameters and network topology for graphical and digital representation of the complex circuits to be measured easily. Which means actually whatever the various network reduction techniques that we are going to use, okay, or we are applying to reduce the network is, or why we are going to apply these various electrical network reduction techniques. These all network reduction techniques are used to reduce the complex circuits into a simple equivalent circuit, or to measure the values of current and voltage, okay, at various electrical what is that components like resistor and inductor and capacitor, okay, and without solving the internal voltage and currents. So that is one of the major advantages of the 2-port network parameters that we will discuss in the upcoming classes. And finally, the CO6 is, at the end of the course, the student should be able to illustrate the importance of the dual network for comparing both mesh and nodal networks. So these are the 6 course outcomes for the course electrical circuits. So after successful completion of the course, the student should be able to do the various things from the electrical circuits. So that's why for every course, the course overview and the course objects and the course outcomes are very, very important in outcome-based education system. So that's why before going to start the course, the student should go thoroughly what is the course overview. So from the course overview, he can able to know, okay, what are the concepts that he is going to learn, in brief, not in detail, and why he is going to learn and where he is going to apply these concepts in the real-time applications. This information we can get from the course overview. And when coming to the course objectives, so by taking this course, okay, what students will try to understand and we will try to learn. So which means what are the concepts that he is going to learn from the course. So which will represent which the student can understand from the course objectives. And course outcomes means after successful completion of the course, what student can able to do. Okay, which means what are the concepts that he can understand and what are the concepts that he can able to apply in various applications or in the courses which he is going to learn in the upcoming semesters. And then when coming to the course syllabus, so usually like all the courses, this course also having the 5 modules, and the first 2.5 modules for the CIE 1 and the second 2.5 modules for the CIE 2. So that is continuous internal examinations. So here the module 1 is about the introduction to electrical circuits. So which means some basic definitions that you can we are going to learn from, and the basic laws which are associated with the electrical circuits, and the basic properties and characteristics of the electrical circuits, and what are the various elements present in the electrical circuits. Okay, so and what is the relation between the various parameters present in the electrical circuits, like voltage, current, power, resistor. What is the relation between each, that we will learn from this module. And also some basic concepts of the single phase AC circuits also we will learn in this module. Then when coming to the module 2 is the analysis of electrical circuits. Okay, so which means by understanding the basic concepts of the electrical circuits, we are going to analyze the electrical circuits by applying the various laws. The various are the basic electrical laws. Okay, so which are the Kirchhoff's laws. Okay, and the nodal analysis, mesh analysis, and star to delta, delta to star conversion. Okay, so by using these concepts, by using the basic concepts of electrical circuit. So we can understand, or we can apply these, or we can analyze the electrical circuits. Then when coming to the third module, this is network theorems. Of course, these network theorems are also a kind of network reduction techniques, but here there are various network theorems, and every network theorems having their own own procedure. Okay, so to reduce the complex networks into an equivalent simple network. And in this module, we will discuss the various procedures to apply these network theorems with DC as well as the AC excitation. And then coming to the module 4 is about the magnetic circuits. So what are the basic laws associated with the magnetic circuits, and what are the various basic concepts which are associated with the magnetic circuit, that we will discuss in here in this module 4. And in module 5 is the two-port networks and the graph theory. So two-port networks and graph theory both are different topics, okay, but these two topics we are going to learn in the module 5. Then first we will start with module 1, which is the introduction to electrical circuits. Okay, so first we will discuss the basic concepts of the electrical circuits, and then we will discuss about the single phase AC circuits. Okay, so at that time, I will let you know what is the major difference between DC and AC excitation. So before that, the concepts are the circuit concepts which we are going to discuss are with DC excitation. So first, before going to the basic definitions which are associated with the electrical circuits, which is what is current and what is voltage and what is power and what is Ohm's law. These all are you have already studied in your +2. So and the students also having some basic idea what is current and what is voltage and what is power. Of course, anyway, we will again discuss in detail about the basic definitions of the various parameters present in the electrical circuit. But before going to that, so let me explain about what is open circuit and what is closed circuit. Okay, so here in open circuit, the electric current does not flow from an active energy source to the connected load or other components due to the incomplete path. Which means the current or the electric current will flow only in the closed circuits. But in the open circuit, the electric current does not flow from an active energy source to the connected load. So here we should understand what is meant by the active energy source and what is meant by the connected load. So for that, let me take a best simple example. So let me consider one battery and one bulb. Right. So if you want to glow the bulb, we have to connect, because this bulb having the two terminals and the battery also having the two terminals. So the bulb you should connect across the two terminals of the battery. So let me put one switch here and then I am connecting the second terminal of the battery to the second terminal of the bulb. If you want to turn on the bulb, okay, so when the bulb will turn on, when an electrical energy will supply to the bulb, then only the bulb will turn on. Okay, so here there are two components, one is the battery, another one is the bulb. So in these two components, we should know what is the active energy source and what is the connected load. Here, the bulb need an energy to glow. So what kind of energy the bulb need? That is the electrical energy. So here, this battery is the active energy source. So which is the electrical, this battery will supply the electrical energy. So that's why here this battery is the active electrical, the active energy source. And the load means, because here the bulb is utilizing the power supplied or the current supplied by this battery. So that's why here the bulb is the connected load. Okay. So which means in open circuit, the electrical current does not flow. Okay. So because of the open circuit means here you can see here these two wires are not connected. Okay. So in between here it is an open circuit. So this is called the open circuit. Okay. So that's why then there is no current flowing through this bulb. Okay. So according to this, okay, electric current does not flow from active energy source to the load. So which means from battery to the bulb. Okay. Due to incomplete path, because here the path has been braked. Okay. So an open circuit makes an incomplete path to flow the active energy from the source to load. Yeah, this is the incomplete path because here the path has been braked here. Okay, by using this switch. That's why when you turn on the switch, the bulb will glow. When you turn off the switch, the bulb will turn off. Okay, so on off means here open and close the circuits. That's it. Open and close the circuits. So which means in an electrical open circuit, the current does not flow. So which means the current is zero. The current does not flow. That's why the bulb will not glow. So that's why this state is called off state position. The open circuit is nothing but off state position. Okay. So which means any electrical component. Okay. If you are turning off is nothing but you are making an open circuit. Okay. So which means you are forcefully making an open circuit to stop the flow of current, so that equipment will turn off. That is the open circuit. So by using the switch, we are making open and closed circuit. Then when coming to the closed circuit, here you can see, in closed circuit, the electric current flows from an active energy source to the connected load. So which means if you turn on the switch, okay, so which means if you are connecting these two terminals by turning on the switch, then the current will flow from an active energy source, which is from the battery to the load. Then the bulb will glow, which means this is the on position, on state position. So in our home, you are turning on and turning off the switch is nothing but you are making an open circuit and the closed circuits. That's it. If you are turning off the switch is nothing but you are making the open circuit so that the current does not flow. Okay, so which means it is in the off position, then the bulb will not glow because you are breaking the connection between the energy source to the load. So energy source is battery here, okay, and load is bulb here. Okay, in your home, okay, the source is electrical energy which you are getting, okay, and here load is any electrical appliance. It may be fan, or it may be refrigerator, or it may be washing machine, whatever it may be. Okay, so you are turning on and turning off is nothing but you are making open circuit or the closed circuit. Turn off means you are making open circuit, so that's why the current does not flow in the circuit. Does not flow from the source to load, so that's why it is in the off position. And when you are closed the circuit means you are turning on the switch. Okay, by turning on the switch, you are making the circuit is closed, so that the current will flow from the source to load, so that that particular equipment will turn on. This is the difference between the open circuit and the closed circuit. And here, for this, you can see here one example. You may get a doubt. Okay, so as we can see, the bird is standing on an electrical wire. Here you can see the bulb is standing on an electrical wire, but it is not shocked. Why? Okay, and here you can see even though not only the bird, you may get because of this bird having the lightweight or some other reasons, you are telling that this is not get shocked. But even though here a person, okay, let us consider a person is hanging in the air by holding an electric wire, but the person is also will not get shocked. Why? And in the second case, as you can see, if the same person holding an electric wire by standing on the ground, then the person will get shocked. So if the person is holding an electric wire and he is hanging in the air, then he will not get shocked. But here a person is holding a wire but he is standing on the ground, then he will get shocked. Why? Here also the same concept of open and closed circuits, because as we discussed in the open circuit, the current will not flow. Okay, so which means here it is an open circuit. This current is flowing through his body, okay, but from here, how it is closed, there is no written path. Okay, so that's why this bird and person are not get shocked, but here this ground will act as a, in sometimes in your homes, okay, so earth. If you are having earth, then you will not get shocked. Okay, so here, which means this ground will act as the written path to the flow. So that's why here this person will get shocked. Of course you will get, but don't try at home. Okay. Then here you can see a simple animation circuit. Here if you observe, when you are disconnecting these two wires, which means it is an open circuit, then the bulb will not turn on. But when you close these two contacts, then the bulb is turning on, which is nothing but this is the switch. So switch is nothing but just you are making an open circuit or the closed circuit. Making an open circuit is nothing but the turn off, and making the closed circuit is nothing but the turn on the switch. And again the same example here you can see. if you connect a battery, this is the active energy source. Okay, and if you are placing a switch, so this can make open and closed circuit. And here if you are connecting a active load across these two terminals, as you can see, if you turn on the switch, then the current will flow, and if you turn off, then the current will not flow. So that's why the bulb will not glow. Next, here let me tell you the very basic or simple differences between the DC source and AC source. What is DC source and what is AC source, and how DC source will represent and how AC source will represent. I mean, how you can identify whether it is a DC source or AC source, right? Okay, so here you can see, yeah, when coming to the electrical circuit, this is the voltage source. Okay, I mean, again in detail we will discuss how to represent voltage source and current source, and what is difference between voltage and current source, and what are the various types of sources also. So here this is the voltage source, and here as you can see, the DC source is represented like this. This is the DC VDC, let us consider. So the voltage source, the DC voltage source. Okay, and when coming to the AC voltage source, which is represented by like this. This is, let us consider VAC, the AC voltage source. And why this DC voltage source is representing with this plus and minus, and why here the AC voltage source is representing with this symbol? Because as you can see here, if you represent this both DC and AC voltage source in graphical, here this is the voltage and this is the, I mean the magnitude of the voltage, the y-axis, and x-axis is the time. Okay, so as you can see here, the voltage line is always constant. Okay, but it is having the polarities, because here this is the plus V, it can be also like this also. So here this is the minus V, which means the DC voltage having both magnitude and as well as the polarities. Okay, both magnitude and as well as the polarities, which means here V is the magnitude and the polarities means whether it is a plus V or the minus V. Okay, plus V or the minus V. And when coming to the AC here, the AC having both magnitude as well as the direction also here. Okay, because here usually the AC voltage waveform is represented by a simple sine wave. Okay, that's why here the symbol of the AC source is also something like this, right? Because as you can see here, this is having magnitude and as well as the direction. Okay, so here it is flowing in this direction, and after off period it is flowing in the another direction. So at every instant, okay, both magnitude and the direction are different. At every instant, both magnitude and direction are different. But in case of DC, as you can see, at every instant, okay, the magnitude and the direction is same. Let us consider here T1, T2, T3, T4. Okay, in all these cases here the magnitude is V and the direction is like this. But in case of AC, let us consider here this is T1 and this is T2 and this is T3. Okay, so T1 the magnitude is different, let us consider V1, and T2 the magnitude is different, let us consider V2, and here T3, here V3, and the direction is also here up to here it is in this direction, and then the direction is changes. Okay, so this is the basic difference between the DC and AC. Okay, and you may get doubt, okay, so usually in our house, which type of excitation or which type of current we are using, which type of current we are getting, whether it is AC or DC. Okay, as you can see in every home appliances, there is a nameplate details of that particular electronic device. Either it may be refrigerator, or it may be what is that, washing machine, or it may be fan or iron box. You can see there, okay, the voltage current and as well as the frequency range. Okay, so here usually the standard voltage, okay, of the DC voltage, source is usually 220 volts. Okay, and DC it doesn't have any frequency, and when coming to the AC it is 230 volts. Of course, some plus or minus 10 to 20 is there. That's why, as you can see in every electronic appliances, okay, the voltage rating they won't mention a constant value. They usually mention from 200 to 250 volts. AC single phase, like this you can find on every electronic equipment. Okay, which means here in between this 200 to 250 also this particular device will work efficiently. And of course they will mention some current also. Okay, and in AC again single phase, three phase is there. Okay, that we will discuss what is single phase and what is three phase and all. And the frequency is around 50 to 60 Hz. In India, the standard frequency that we are maintaining is 50 Hz. Okay, in some other foreign countries, you can find some 60 Hz frequency also. Okay, that we will discuss why the difference is there and why we are maintaining 50 and why they are maintaining 60. That we will discuss in further classes. Okay, so they also, I mean, in the frequency also, they won't mention a constant frequency. Okay, because practically the frequency every time it may or may not be constant. So that's why they usually mention some 45 to 55 or some 40 to 60 Hz. Okay, so this is about some basic information about the DC source and AC source. Thank you. In the next class, we will discuss the basic definitions about the basic definitions and the basic laws associated with the electrical circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.